Morning, guys. Hi, my name is Karan, and we will be solving a couple of DSA questions. So, let's start right away. First, I will like solving this CP31 sheet, like to improve my CP6 skills. I have solved the 1000 rated questions. I started from this only, and currently on 1100 ones. Let's create a new page. Today is my first live stream, so let's see how it goes. Where can I see the chat? Where is the chat? Oh, I think I should focus on solving the problem. I will look at the chat later. Building an aquarium. You love fish. That's why you have decided to build an aquarium. Okay. You have a piece of coral made of n columns. The ith of which is AI units tall. So, like in the given figure, we can see it's not this. We have n columns. N columns, the ith of which is AI units tall. This. These are all columns. N columns. Like they have some heights. This is A1 of height. This is A2 height. A3 and this AN heights. Afterwards, you will build a tank around the coral as follows. Pick an integer h greater than equal to 1. The height of the tank. Build walls of height h on either side of the tank. Okay. Then fill the tank up with water so that height of each column is h. Unless coral is taller than h, then no water should be added to this column. Let's see what it is trying to say. I'm not getting it in the first go. Pick an integer which also. Then fill the tank up with water. The height of each column is h. Okay. Eventually the height will become same for all after filling the water unless it is taller like in this given figure. Okay, here is an example. 3 units height, 1 unit height of height h is equal to 4. You will end up using a total of w is equal to 8 units of water. 1 unit here, 3 units here, like 1 here, plus 3 next, plus 2, and this is 4, this is more than 4, this will be 2. So total of 8 units of water used. Right. This is like, I think, trapping rainwater type problem. Solved a similar problem. You can use at most X units of water to fill up the tank, but you want to build the biggest tank possible. Biggest tank possible in terms of water units, I think. At most X units of water. So we have to maximize the water capacity. Maximize the water capacity. Like select h less than equal to x limit of water units. So let's look at the constraints. Time is 2 seconds. Okay. Test cases n and x. N is 2 into 10 की power 5. X is 10 की power 9. The number of columns. Okay. And the second line is giving us the heights. So like we can conclude from the given constraints that our solution should be less than n square. X is 10 power 9. I have given input in this format and x a1 a2 and so on till an. This is the first test case, then second test case, and so on. So what can be our approach? This is the given example only. 4, 3 in x10 1 1. Let's see in this test case. Accepted time complexity. Oh, linear solution and log n and like similar solutions all less than n square. We can go here. Nice, nice, nice. Let's see this test case number 2. Trying to find the pattern using the given test cases only. 3, 10. This is 1, 1, 1. So let's draw. This is 1 unit, 1 unit, 1 unit. Given x is 10. So this is saying the answer only 4. How? If we fill 1 unit here, then x is 9. So we have to level up. The water will be filled here also and here also. So to make this is h is equal to 1, h is equal to 2. Like to increase one level of water, we will have to use 3 units of water. So x will become, at h is equal to 1, x will be 10 minus 3 is equal to 7. And to fill the next layer, h is equal to 2, same 3 units of water. So we can see that for increasing height by 1, 3 units are used instead of 1, as the water will be distributed uniformly. X is now 7 minus 3, 4. Same for the next level. We can go up till this x is greater than 1, greater than equal to 1, or greater than 0. We can say x. Now x will be 1. 10, 4. This is h is equal to 3. This will be the 4. I missed one level. H is equal to 4. So as we can see, at h is equal to 4. Oh. Coming back. is equal to 4, the x will be left 1, and for if we try to fill h is equal to 5, then we will not be able to fill it as we don't have enough water units. Here it becomes 10, and now we cannot uniformly distribute it, so we cannot have h is equal to 5. Okay. Mm, so 4, 1, 3. We can use only this is a very tall height and only one, and we can fill all this water because only one column is present. What is x? Like we cannot increase height one by one and fill all the levels, because that will be a slow solution. Because if we start from like minimum AI actually, from all of the given heights and start filling like brute force solution type, like here it is height this, like this. If we find the minimum height, let this be the minimum height. A1, A2, A3, A4, A5, minimum height. Then like we can sort them. If we sort them, like sorting on like is becoming an idea here. If we sort them, this is a good test case, so let's stick to this only. 3, 1, 2, 4. 6, 5. 6, 2, 5. 3, 1, 2, 4, 6, 2, 5. 6, 2, 5. If we sort them, this will take and log in. Then we will get 1. Let's see, the indexing 1, 2, 3, 4, 6, 5. Gap from 6. We sort them 1, 2, 3, 4, 5, 6. Let's write the indexing here. This is 1 in original, like in original array this was 1. This is 2. We have 2 2s. 2 2 5 3 0 4 3 5 6, and 6 is at index 4. So if we sort them, how should we approach this problem? When I've done this height wise, like it depends on the difference of the neighbors actually, not solely on the individual height, because now like they are in Mr. Potter, because I thought that we can start in a brute force solution. We can start from this and fill level all them to the same level which are less, but like this is not going to work, I think. Like, now I am seeing like the absolute difference between them actually matters, not solely the height. Like this is two absolute absolute difference of 3 and 1. This will be the 1, this will be 2, 2, 4, 3. Hmm. We take AI minus AI minus 1. Now the actual difference is minus 2 degrees of height plus 1 increase of height minus 2 degrees of height plus 2 increase of height minus 4 degrees of height and then plus 3 increase of height. If we take the actual values instead of absolute, let's think the most inefficient solution first, I think, then we can optimize it. What is division for E problem? What can we do? Processing. So like if we take this center, try to fill 1 unit here. try to fill my unit here, it will fall like distributively. I think we should make our diagram. Zero, 3, 6, and then 2, 6. Okay. If we take this index and try to like make its height 4, then the difference is minus 2 already, and this plus 1 also will be needed for this, only for this height. So total, if we try to increase this height by 1, this will be required a absolute a1 minus a0, and this is the difference with this level, and if we are increasing by 1, so plus 1 for that, and this is equal to 3 in this case. So we have filled this, and similarly for like this is a double for loop, I here, j here, we have calculated this in j here, so same absolute is equal to 1 absolute a2 minus a0 plus 1 will turn out 2, and this will be, we will have to check the height level first. This is the structure, let's write I plus plus we have some current height. Current height is equal to, I have a doubt in this, we'll say this later, what should be the first current height? It should be the minimum of all the heights or the zero indexing height. I have to see this later. Water required for this current height. For we are here, if we try to increase this height, then it will also take into account the previous heights. So we will have to start from 0 only. J is less than n I plus plus, sorry, j plus plus. J is equal to I continue because it is on same tower or height. If a of j is equal current height which we are trying to make, then we cannot fill the water. Like in this case we are making h is equal to 4 and this tower is already 4, this is more, so we are not filling, like adding this water unit in here for making the level 4. We are only considering the towers with height less than 4, like this one, this one, this one, and we'll take this one. So in this case also continue, else the required water units will be summed up plus equal to this quantity absolute a of j minus ai plus 1. So we calculated for this height. This will be, this is at 2 and 2 water units will be required. 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So total water units required equal to 8, and we are given x as 9, so we subtract it, x after like each I we are subtracting this. Water requirement, if x is less than 0, then we will not be able to make this height. We will not be able to make this height. So we have to check next. Actually, this will be like, we will start from minimum h. So it is making more sense instead of index line. I'm addressing this instead of taking the first height. We'll have to check. This is a brute force solution. I know that this will not work, but let's think this through so that we can optimize it later. H is equal to like minimum height is this. H is equal to 1. which is equal to 1. This is at index 1, and then we will start. Actually, what can be the maximum height? It can be more than this height if we have enough water units. Like what can be the maximum height? Minimum will have to start from the minimum of this array. Minimum AI. Let's write it this way. H belongs to interval minimum AI. 0. If we don't have enough water units, this is like very tall and x is equal to 1. Can fill this. If we have, and like this is very short. This is like in this case only. We can level up. If we have multiple smaller. Can we have a zero height, like zero capacity of water tank? Can fill them here, if not here. Minimum +1 +1, but will require here. So minimum capacity can be like, if we take the minimum, this is of same level, here we will require 3 water units. If this is of same height of this minimum, then we can fill this by 1 water unit only. If we have only 1 water unit, can integer h greater than equal to 1 the height on the build walls on either side of the tank. Pick an h. Okay. So h is starting from 1 and going on till like it can be more than this value. So let's like take 10^9. Is this a binary search on answer type question? Because I think we will have to like reduce the search space in this manner only. Right now we are taking an square approach. Let's complete this. Then we will see the is it applicable to use binary search on H. Here can we get like we can move and decide only actually we can do this. I think this is a very strong idea here because eventually we are checking for H and then checking can we make it. If yes, then try for the next height, and if we can't, then we like in this n square case we are stopping, but in this case we can reduce our search space to the like yes we can. I think we can do this. Break. Take this as h. Is less than 10 power 9. H plus plus. Water required 0 initially. G is equal to 1. J is equal to I in the same tower. No, J is equal to AJ is equal to H. Continue AJ greater than. This is same becoming same condition. This is redundant. We can continue else water plus equal to okay. Then we are taking the minus. Then if it becomes negative we are exiting, and the previous height which we made like the previous height for which it calculated as positive will be our answer. Current height else current height is equal to H. I think this solution like is logically correct. I think, but this will be a slow solution because H is going from 1 till 10 to the power of 9. So it is not possible, and like we can only have 10 to the power 8 operations in 1 second, 2 second time limit, and also then we are going through all the elements. So O of H into N solution is here. This is O of H into N solution. So we can implement it to see if it is the correct approach. But I have a strong confidence that this is logically correct. And the next optimization should be like instead of linear searching, we should have a binary search on H. So that will make the time complexity, like we will have to do this inner loop of n iterations, n, and we will have to binary search the h value from the given range of 1 till here. So this will take log h, log h, log 10 to the power 9, or log h. Log h. It will take some log factor. I think I will have to see the here also, because h is our answer. So can't have h in a time complexity, like this is based on inputs. Worst case, this will be 10 to the power 9 into h, and in the ideal case this will be 1 into n. So this is h only, I think. Log h into n. Let's see. Like if this solution works, then we can implement this binary search easily, because logically it is same, only the method of searching becomes faster in case of binary search. We can apply binary search here because we can, like, we have some start here is equal to 1, 10 to the power 9. This is the end, and our mid will be the middle point. So it will be 10 plus 1 upon 2. So something will be there. Let's take it as x1, or take it as y. So if we will try to make this height h, so all the greater than y heights will not need any water, and all the columns with height less than y will need the water units. So we will sum up across all the array through this loop, and we will check the amount of water required in this case for this height, for making this height, and if it is greater than, like given x is greater than or equal to this water required to make this height y, then our answer, current best answer, will be this y, and we will try to search in this space to search for the better answer, because we have to maximize the height, maximizing the height h depending upon the x value water capacity. So this is our current best answer. So to search a better answer, we'll have to search better height values. So we will make the binary search like start pointer to y plus 1, like mid plus 1 index. I think this is going to work fine. And if we have, then answer is this, and mid is equal to mid plus 1. Start will become mid plus 1, and then we will again calculate mid and check if the x value is less than the water required value. We will not be able to make this height if this case is present. So we will have to search for a lower height. Then we cannot update our answer. X is water required. Then we'll have to simply make n is equal to mid minus 1. And we cannot update the answer because we cannot make this height. And this will, I think we are ready to code this up. Let's try to code the linear solution first. And if that gives time limit, we can implement this binary search, and if this gives a wrong answer, then it will definitely give a wrong answer in this case also, because essentially the method is same, but we are exploring the search space in different manner. One is linear search, the second one is binary search. So binary search provides the speed up here, and it should be accepted solution like this should be accepted time complexity, because it is better than a brute force solution. In worst case, let's calculate it. It's 10 power 9 n is 1 to 10 power 5. So n of 9 log 10. So this is less than 10 to the power 8. So this can be accepted easily. Let's go. The idea is clear. We can now code it fastly. First is n, then we have x, n, x, and we will hide array print height. Let's take n. AI is equal to h. This is, we have accepted the input. Now we have to do the binary search. So initially we will first, I think we should implement linear search to see the correctness. Binary search will then definitely work. We will have a guarantee. Let's int current height is equal to 1. I is equal to 1. I is less than h. H is less than 9. The given hard limit is 9. Such h always exists. N is given and x is given. X, h. This should be x. X. No, this should. Let's see it. H equal to and what are required to make this height. I have to traverse the entire array. I space if the height of the tower is less than greater than equal to, then we will have to skip it. Greater than is equal to h, then continue. Otherwise we'll have to sum it up. What are required plus equal to absolute h absolute. Here we are trying to make height 4, so 4 minus 1 will give this 3 units. Absolute h minus ai. So after traversing the whole array, we will have the water required for making this particular height. So that will become if x minus equal to current height. To my make height for 2, we will require 1 unit. We will require 1 unit. I think we are double counting. So in the next height is equal to 2, like for height is equal to 1, we will require 0. For height is equal to 2, we will require 1 water unit. And in next, the height of this tower will become 2n. It will not remain 1, but in this we are considering it as same. It is actually dynamic. Okay, it is changing. So I think we should fix this double counting. We'll have to update this height also. Height of each column is each column. So like we cannot have here we are making height is equal to 4 and this should remain less. So we'll have to make all. We'll have to update the heights also. We'll have to update the heights. This will be the total water required. Then we'll have to update the heights. Like if x is less than 0, then break. We cannot have a better height. Else we have to update our answer. We can, and also our heights. So current height is equal to h, and again a for loop to update our heights. We cannot do this updation here because we are not sure that whether this sum will be less or more than x without calculating it fully. So it will be still n square only, but we will have two for loops inside a for loop. So update all the heights less than in less than h, because it will rise up till the h level if this is the possible answer. This will be the minima for the next case. I think this is good to go. And if we break here, then simply print our best answer found. Let's run this on example. 4, 4, 2. I'm getting. We'll have. This is wrong. First, this case is passing. The two test cases on which we took this is passing, but on the rest it is failing. Four, we have one water unit. 1, 4, 3, 4. So if we try height 1, it is already 1. And height try 2. Okay, minimum height plus 1. Current height should be minimum, yes. Current height possible is minimum. We try 2 here. We try 2 here. Then we will require 1 water unit and this will be exhausted, so 2 will be our answer. If we take here in this case 1, then water 0, so if greater than h, continue 0 water level. This is wrong, this statement. I think now it will run. Okay, last test case is big, so this is filling. Let's remove this. Because this is a so slow solution, right? Yes, the answer is correct. The idea is correct, but this is brute force, and last test case has a big x value and low n value, so it will take a lot of time. So now we will have, ideally the binary search should work fine and should work for the last test case also, because it will have a better time complexity. Let's implement that. This updation idea, I will have to take this into consideration. Commenting this out. am happy that I am able to get the idea on my first live stream. So much. Binary search knowledge. This can be minimum plus minimum height. This can be minimum height. Let's take this. If this gives TLE, we can optimize it by having minimum. Start 1, end is equal to 1e9, mid to 1, start plus end by 2. 1e9 plus 1 is possible, cannot overflow in the integer range, while start is less than end. For this current height, for this mid, we'll have to search. Essentially all this part can be copied. So we think I will copy all this part. And water required is equal to 0 less than mid. Water required is equal to mid minus AI. If this is possible, then I will have to reduce the search space. This is the possibility check. Break. Else no, we don't break. In this case we reduce the search space. Yes, so I'll have to search space in lower side, so end will equal to mid minus 1. Right. In this case, if this is not possible here, then it can be possible in the lower values. Else, if it is possible, then we will have to update our heights and search for bigger edge. Current height is equal to mid mid and start is equal to mid plus 1. And we will have to recalculate the mid for next iteration. I think this is good to go. Let's start binary search. Is going wrong. Start placing by 2. Is this overflowing? Because we are summing up the values, so it can be the possibility. Because if the mid is very big, then this can overflow. This is going wrong. Printing the mid. It is not reducing. If x is less than equal to 0, then okay, x plus we will have to reset the x. Should comment out the mid values because it was not decreasing. So still mistake. Let's check this. X minus water required is less than 0. Okay, we will have to update here also. If x minus required is less than 0, then end is equal to mid minus 1. Else, okay, x minus equal to not required. Getting one less. 4 3 4 3 2 1 335 334. Why is that the case? Mm, we can essentially plus one here to fit this, but I'm not getting the idea as why is this happening. One water unit. Let's try this test case. See whether this increases the efficiency. Hmm, it is running, meaning it has increased the efficiency, but it is leading to wrong answer. We should have the minimum height as the minimum. A dot begin, A dot end. Algorithm header. Okay. This should be a current height. This one. Okay, we are getting now 442335, 442335 last test case. I have a difference of two lines. Let's see what is happening. How many zeros are there? Okay, we will have to take this. This is 1e9. If we take this plus 1, we take this as what can be the maximum height? Maximum height can be a big number also. It is upper bound of h. If we like increase the search space till 5, also it is 1. It is 1. It will like, yes, it is easy to see that how this answer is coming up here, because essentially our water units will be stacked up on this one height element, so it will result in this number plus 1. This is the answer. But here, if we have current height minimum 1, okay, and water units will be used 1, the linear case, minus, then What is this number actually? 1, 2, 3, 4, 6, 7, 8, 9. 1e9. Answer is 1e9 plus 1. Searching in 1e9 plus 1 space. This. Okay. So it was not searching this search space correctly. But I am still unsure about the upper bound. Like it can be greater than 1e9. In this given test cases it is passing, but while submitting it is possible that a bigger answer than 1e9 plus 1 is also possible. So I think we should go for long. We should convert all this in long. Let's make it long. Or first see, this is passing or not. Int max, best case, int max. Here it is. So 1e9. 2e9. What can be a search space? Best search space. What is the upper bound? Maximum height. No, it can be more than that. What is the upper bound on answer? Lower bound is 1. 1e9 is fine. This is becoming too slow for search. 2e9. Plus 1. If this is x, I think we should say x limits are 1e9. This is the worst case. 1e9. And only one tower is present. If 2 is the height, then it will be plus 2. If this height is 2. If this height, what can be the maximum height? AI is also 1e9. So in worst case 1e9 plus 1e9 2e9. 2e9 is the actual 1e9 till 2e9. 2e9 is the upper bound. Because if we have many towers, then they will consume this water fast. If we have only one tower, then it will be consumed slowly. 1 unit at each level. Otherwise it is summation across all. So 2a9 is the search space, but it is slow for that. 2a9, let's see. think we have to optimize it further to increase the search space and include all cases because it is still slow for the worst cases. The actual search spaces actually the possible heights are in range h is equal to 1 and h is equal to 2e9, and right now we are searching only in this part, but it is possible that answer lies in this, like in this case, which is possible. Like we have 1e9 water units and n is equal to 1 and the array is 1, and if we this will have answer 1e9 plus 1, so answer lies here. And if we increase it till this case also, then also we can have 1e9 element as here. It is given that this can be 1e9, so we can stack this up 1e9 plus already 1e9 height plus this all water units here of 1e9 height, so height can become 2e9. So this is our search space in worst case. The end is this, but this code here right now is slow. This binary search is still slow for 2e9 case, so we'll have to either change our approach or optimize this updation, something like that on this line. Let's try to submit this first. What can I will just random guess. 1e9 plus 1e4 and 1e9 plus it should be less than 9 and more than 4. Let's take it as 8. Okay, 1e8. This is too big for this. Let's take 8 only. Can we increase this further? 7. Int max in terms of power of 10. Int max. Actually, int max should be a source case. 2e9. Let's submit this. It will not be accepted, but I need to see like how many cases it will pass. Like this is the case I'm talking about. This case. This will have answer 2e9, but we are not searching in that search space. If we search, then it is leading to TLE. In this case, we failed on this test case right here. So I think we should say this later because I think I'm exhausted now. Now, how should we fix this? Essentially, I think the main idea is binary search on answer only. And we will have to see some. I have to optimize this code further. Okay, let's end this stream. I will like update the answer in the tomorrow's live stream. I will discuss how I optimized this binary search on answer code in tomorrow's live stream. Nice to complete my first live stream without going absolutely blank.